Hello, this video is for 7.1 Simplifying Rational Expressions, Objective 1, Evaluating a Rational Expression. When we evaluate a rational expression, we look at our rational expression and they come in the form of a ratio of two polynomials, p over q. Because there are numbers that you can plug in for your variable and make your denominator 0, we don't want that to happen. So we say that the denominator q cannot be equal to 0. For example, in practice 2, evaluating this expression when x equals 2, we get 5 divided by 2 minus 2. When we have 5 over 2 minus 2, that's 5 over 0. Now recall, when graphing lines, when we had a vertical line, our vertical lines, when we graph them, in going from any point to another point, we would say that it was all rise and no run. Because you're rising any given number, the run was 0, we called this slope undefined. Same thing happens here. When we evaluate expression where the denominator is 0, we say that that evaluates to undefined. So here's some examples of rational expressions, any ratio of two polynomials. So we can evaluate any of our rational expressions. For example, the first one, when evaluating when x equals -5, we would have 3 divided by 5 times -5 plus 1. That's 3 over -25 plus 1. And this time, the algebraic expression or the rational expression evaluates to 3 over -24. When we simplify that, we get -1/8. If we evaluate it when x is equal to 3, then we would get 3 over 5 times 3 plus 1, and this time it would be 3 over 15 plus 1, which is 3 over 16. We say that those values make the expression defined. If we evaluate x squared plus 6x plus 9 when x equals -5, in my numerator I have x squared, so that's -5 squared, plus 6 times -5 plus 9. The denominator is -5 plus 1. That gives us -5 plus 1. -5 squared is 25. 6 times -5 is -30 plus 9. So that works out to 25 minus 30, which is -5 plus 9. -5 plus 9 is 4, and -5 plus 1 is -4. At -5, this expression works out to be -1. And lastly, if I evaluate it at 3, we have x squared, which is 3 squared, plus 6 times 3 plus 9, divided by x plus 1, or 3 plus 1. 3 squared is 9. 6 times 3 is 18, plus 9, divided by 3 plus 1. The numerator is 9 plus 18, which is 27, plus 9, which is 36, and 3 plus 1 is 4. 36 divided by 4 is 9. Now that we know how to evaluate a rational expression, we will then, in the next objective, look at what values will make the expression undefined. And for example, if we're looking at x squared plus 6x plus 9, if you let x be -1, then the numerator is -1 squared plus 6 times -1 plus 9. When I divide that by -1 plus 1, this time the denominator turns into 0. The numerator turns into -1 squared as 1, minus 6, which is -5, plus 9, which is 4. The numerator doesn't really matter in this case because with 0 in the denominator, this evaluates to an undefined expression. And remember, that's what we don't want to have happen. And that's why in the definition for rational expressions, we say where the denominator q is not equal to 0. So in the next video, we'll look at how to find out when a rational expression is undefined. Again, that's 7.1, Objective 1, Evaluating a Rational Expression.